Hello everyone, my name is hadar-hai and with me is Ariel Lulinsky, and we are going to present you our final project of deep learning course. We chose to focus on comparing ViT and CNN models on the problem of binary image classification, especially for tasks of images of very similar classes, and specifically for Asian versus African elephant dataset. Similar tasks have previously been studied on problems such as art classification, cats versus rabbits, sheepdogs versus muffins against chihuahuas, and more. Such tasks are difficult even for humans. For example, in the problem of classifying Japanese art versus art nouveau, the work we found showed a human classification accuracy of 82%, which is not amazing. Let's talk briefly about the pros and the cons of CNN and ViT. Regarding CNN, it excels of processing images efficiently through convolutional layers. It also learns hierarchical representation for robust feature extraction. And as we all know, CNN has performed impressively in many benchmarks. The disadvantages of CNN are the limited global context understanding. Also, it requires many parameters, and it leads to increased memory usage and longer training times. For ViT, in comparison with CNN, it uses the entire image, and it processes the entire image, and then it captures long-range dependencies and understands the global context. The self-attention mechanism helps ViT to focus on relevant parts of the image. Additionally, ViT can be pre-trained on large dataset and then fine-tuned on different tasks, like we did. As for the disadvantages of ViT, because of the self-attention mechanism, it can be computationally costly to use it. And also, if you want to train it from scratch, you need a lot of data in order to do it. Now we are going to present you our dataset. Our dataset contains two classes. One is African elephants, and the other one is Asian elephants. The dataset is quite small. It contains about 1K images. And we split it in the following way, for train, validation, and test sets. You can see here some images from the dataset of the different elephants kinds. In order to distinguish between African and Asian elephants, there are a few keys which you can all see and learn. One is the ear shape. If you can see, African elephant ear is bigger. You can also see that the texture of the skin is different. For the Asian, the skin is smooth, and for the African, the skin is rough. Now we're going to present you our data augmentation. We used Cornea for data preprocessing. We randomly resized and cropped the image. We randomly rotate the image. We randomly horizontal flipped it, zoom in, and normalize using the mean and standard deviation of ImageNet. We did this step in order to improve the result, avoid overfitting, and help the network generalize better.
We use the transfer learning technique utilizing pre-trained models, where we just replace the last layer to be with the desired output of two classes. We initialized our weights with the pre-trained weights and had two options for training. Train only the weights of the last layer and freeze other weights, feature extraction, or train the weights of all the layers, fine-tuning. We tried several options, including LoRa-DORA for two CNN models, MobileNet and ResNet, and find the best one using a validation set. Then we applied it to two visual transform models. One is supervised and the other is self-supervised. And looking on the test accuracy, we can see that ViT models outperformed CNN ones. We continued our analysis with the best CNN model, which was ResNet, and the best ViT model, which was DINOv2. We also created a graphical user interface and tried it ourselves and asked some friends. And we can see that for this task, machine methods outperform the human ones. And we can also see confusion matrices and some visual results. So we also looked on the CNN activation maps. These maps are regions last convolutional layers focuses on. we can see that for images with high confidence, the focus is mainly on the objective, whereas for images with low confidence, the focus is not only on the objective, but also on the background. So to conclude, we showed that ViT outperformed the CNN. This is due ViT self-attention mechanism that enables him to capture not only local but also global spatial dependencies and therefore understand contextual relationships between different regions. Also for ViT, we showed that the self-supervised performed better than the supervised, showing its effectiveness in learning representation. And the last thing to mention, especially for ViT, is the importance of large training datasets. In our case, it was ImageNet that contains 13 million images. Thank you.